Bertoncini Bergamo, Leela 1948 series. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. The company L. Bertoncini Bergamo produced a few radio models in particular between 1947 and 1948. This is the comparison between the same advert published by Bertoncini in the magazine Elettronica in October 1947 on the left and January 1948 on the right. Therefore, it is visible the evolution of the three main models, Toti, Leela, and Malumbra, between 1947 and 1948. The documentation for these Bertoncini models comes from the Radio Mechanic Manual, 5th edition 1948, pages 119 and 822. The radio under restoration has a drum band selection switch, which, in the Leela model, appeared starting with the 1948 series. However, there have been multiple runs and only one schematic diagram remains. It is related to what was called 5th series, dated September 1948. The unit under restoration has 4 knobs on the front and has a drum band switch selector. Therefore, it must have been produced in 1948, and its actual arrangement is close to the schematic diagram that is available today related to the 5th series, although not perfectly identical. The company L. Bertoncini Bergamo also produced some radio components, which were used in their radios, the IF transformers and the band switch selector module. The original capacitors used in the radio were mostly Ducati. The Ducati mica capacitors were used also inside their IF transformers and in the band switch selector module. Also, the variable capacitor was made by Ducati, and that series of models was very well advertised in the electronic magazines of that time. The chassis and the dial panel were made using aluminum sheet. Aluminum was much easier to work with for making the chassis and the dial panel, but it has the disadvantage of making extremely difficult soldering on it. Therefore, all the connections to the chassis ground needed to be made with dedicated posts connected to the metal using screws. The unit under restoration suffered from important accidents during its life. It underwent a repair that implied the replacement of the loudspeaker with a fixed magnet type, which suggests that the original field coil was burned and various capacitors had been replaced, especially the electrolytic filter capacitors. Also, the tone potentiometer was replaced with a newer model, but with a much higher value than the available schematics suggest, and therefore also connected differently to obtain a similar effect. Someone or something has broken through the back panel. The loudspeaker is loose and 2 vacuum tubes have been torn from their base, probably as a result of the same accident that broke the back panel. What happened to this radio must have been violent. The loudspeaker is even snapped from its output transformer. The knobs must be removed in order to be able to extract the chassis from the cabinet. The set screws are stuck and some Vaseline oil is applied to allow their extraction. After a few minutes, it is possible to release the screws and remove the knobs. Having removed the knobs, the radio can be laid flat on its front, allowing easy access to the bottom screws that hold the chassis inside the cabinet. But there is something else still keeping the chassis in the cabinet. In a previous repair, the output transformer was installed on the cabinet. Very likely, originally that was attached to the loudspeaker. After having checked the output transformer connection, the transformer can be removed, which leaves the chassis free. It is then extracted and put aside, leaving an empty cabinet. With the chassis removed, it is possible to observe that there are wood chips, which have been used to keep the chassis slightly elevated from the original wood frame. There is also a lot of dust accumulated at the bottom of the cabinet. Before putting the cabinet aside, it is better to clean it, at least roughly. It is now apparent that the cabinet is very light, made of a small skeleton covered with just veneer. It looks much like the sound box of a string instrument. The first thing to do with the chassis is to remove the dial glass, which otherwise could break very easily with any mechanical stress. One of the two brackets is stuck due to a defective screw. Luckily, the bracket is made of aluminum sheet, and it can be gently bent to let the dial glass free. Later also this bracket is removed, without fear of breaking the dial glass, which is now in a safe place. In order to safely remove the top cap connector of a radio tube, it is advisable to put some oil first. The tubes used in this radio are side contact or transcontinental type. To insert them in their sockets and to remove them, it is necessary to tilt them along the correct diagonal axis and very carefully. With all the tubes removed, it is possible to do some preliminary cleaning on the chassis using an over-degreaser and alcohol. A lot happened under the chassis of this radio, including a bad short involving the high voltage secondary winding of the power transformer. For reference, here is a scan of the initial condition under and above the chassis. The schematic diagrams available for the Layla radio models come from the Radio Mechanic Manual. There are two types of diagrams and the components are not numbered. Before starting anything else, it is appropriate to analyze the circuit and draw the actual schematic diagram, even though initially there may be inaccuracies. That would also allow to number the components and to draw the map of the components under the chassis. At this stage, It is also easy to observe that the tone potentiometer of this unit cannot be original because it was installed on the dial panel, without even taking care of insulating the power switch terminals that are so close to shorting on the chassis at the back. This suggests that, in this unit, the location of the tone potentiometer in the circuit might not be the original one. Anyhow, ignoring the difference related to the tone potentiometer, the result is that the circuit found in this unit is closer to the second schematic diagram that is mentioned as Layla fifth series, although not identical. A careful dismantling process can begin, taking care of verifying and correcting the draft schematic diagram and map just drawn. Before that, the components that have just been numbered are also temporarily labeled and photographed in their original place. That might be useful later. Here is the accelerated dismantling process. Please note that all components are catalogued and kept. The original field coil speaker of this unit was replaced with a fixed magnet type, and a resistor was placed in place of the field coil. However, the resistor that was used has a particularly low value compared to what the Layla schematics suggest. This is the dial cord arrangement found in the unit under restoration. There are two independent dial cords, one on the front and one behind the dial panel marked with a dotted line. With this arrangement, one of the cords might slip on the shaft, making the position of the dial pointer very unreliable. The dial cords found on the unit under restoration must have been replaced in some previous repair. Based on the presence of solder residues on the pulley on the front, the original dial cords might have been made of some type of steel. These accelerated clips show the process for separating the dial panel from the chassis. The flywheel should have been removed before leaving the shaft connected to the front panel. The correct procedure will appear more clearly while rebuilding the radio. In 1948, Bertoncini started making their own band selector switch, which is removed in these clips. One should notice that the two screws on the front have different sizes for some purpose, although it is unclear the reason. The variable capacitor is installed on the chassis, elevating it from the surface by using two spacers and a bent flap of the aluminum sheet that makes the chassis. No grommets are used. The right spacers are crucial for the correct location of the variable capacitor in relationship with the dial panel, but that will become apparent while rebuilding the radio. The drum should have been removed before together with the front panel, but that is explained in a later section. Some Vaseline oil is applied to the screws holding the drum to the variable capacitor shaft. After a while, that allows to remove it. The dismantling process continues, removing all the parts still attached to the chassis. The tube sockets require particular care because they are rigid and they could easily break with any mechanical stress. In a normal restoration, these sockets could remain on the chassis, especially considering the care with which they have been installed by the factory. Using soft washers under the rivets for preventing excessive tensions. However, there is a plan for placing soldering points under the aluminum chassis, and that requires removing everything from it. Please notice the use of a wire cutter for removing the rivets. The Bertoncini nameplate is also removed. Everything will be installed back later, but using screws. Soldering on aluminum is like a mystery, and every time the experience is different. What is necessary for sure is a powerful soldering iron, Vaseline oil and solder. Motor oil would be okay, but Vaseline oil makes less residues. The surface must be cleaned, also using sandpaper, and scratched a little bit and covered with oil before soldering. It is unclear if there is any type of solder more suitable than others. However, it has been tried to add teeny tiny pieces of pure zinc to the solder, but with unclear effect. Also, solder containing bismuth was tried with the same unclear result. A zinc plating of the area was attempted too, but that didn't seem to help. Special flux for aluminum was tried, and also old-style solder containing acid flux. These two products are definitely not recommended because they produce awful fumes, terrible residues, and they just don't work. What was noticed instead is that the thickness of the aluminum sheet is relevant. It seems that thicker aluminum sheets are easier to solder to. In this case, the test aluminum sheet is 2 millimeters thick. The following clips, very accelerated but still long to watch, show all the struggle for obtaining the wanted soldering points on the aluminum of the chassis and of the internal shield. No additional comments are made during this section. The chassis is cleaned using acetone. The residues left by soldering on aluminum are removed with the help of a metal brush. Then, 4 small holes are made. They will be used for installing 2 plastic boxes. One of them will host 2 fuses and a few halogen light bulbs. The other one will hide an RF buffer for an external frequency counter. The chassis now has plenty of soldering points, but soldering on them still requires a lot of heat power. Therefore, some copper wire is soldered on the chassis to allow an easy ground connection later while rebuilding the radio circuit. The original tube sockets are all in good shape. They are cleaned and the terminals are tinned before installing the sockets back on the chassis. In place of the original rivets, new stainless steel screws are used, and for consistency, all the other screws will be replaced with new ones. In place of the original soft washers, nylon ones are used. They must be used on both sides, under and above, to make sure that the sockets will not have to stand important mechanical stress when the tubes are inserted or removed. In the end, also the basic ground connections are prepared before moving forward. The power transformer is still operational, but it requires important attention. First of all, it is gently cleaned. The various windings are tested for continuity, and they all seem to be okay. All the wire insulation is in very bad condition, and it is carefully replaced or improved. In particular, this is the center tab for the high voltage secondary winding, which suffered from a dead short and now is in precarious condition. Therefore, a lot of attention is needed for making sure that it will not break. Some solder is applied where the wire has become very fragile with the hope that the remaining strands will not break. The oxidation that developed after the accident makes this simple process more difficult. Later, a drop of hot glue will be put to avoid any more mechanical stress to that point. All the other wires are re-insulated using colorful heat shrink pipes to distinguish their functions. The primary winding connections to the input voltage selector are desoldered so that the frame of the transformer can be removed. Also, the insulation of these wires is in very bad shape. The plan is to use only the 220 volts input. However, even without using the other taps, they must be soldered properly, otherwise the primary winding would end up being open. For this purpose, Some thin copper wire is soldered at the end of these extra taps. Later, all these unused taps will be insulated completely. Before removing the frame on the side of the secondary windings, a drop of hot glue is put to the delicate connection of the center tap. Also, at the base of the common terminal for the primary winding, a drop of hot glue is meant to protect from shorting later. The transformer can now be tested at least without load. Only the 220 volts input is used. These are the output voltages while feeding 210 volts AC to the input. These are the output voltages feeding 230 volts instead. The input voltage selector is removed from the transformer frame. Even if not used for its original purpose, it will be reinstalled later, when the frames will be cleaned and repainted. Now the frames can be cleaned with acetone, removing also most of the original paint. Some tiny rust spots are found, and they are treated with a gel rust remover. Then more acetone is used to remove the rust remover residues. The transformer, the frames and other iron parts are painted but off camera. Now the transformer can be reassembled. New screws are used, but before inserting them, they are insulated with some heat shrink pipe and nylon washers to avoid unwanted eddy currents between the two metal frames. The original input voltage selector is cleaned and reinstalled on the transformer frame. The remaining parts on the dial panel are removed so that the panel can be cleaned carefully and later also repainted. The intermediate frequency transformers are extracted from their cans. They are cleaned with great care using alcohol first, and then acetone. These IF transformers were made by Bertoncini using also red Ducati mica capacitors, which here have been lifted from their original position for allowing a better access during the cleaning process. The aluminum cans are cleaned using detergents and some fine steel wool. To keep isolated the IF transformers from the cans, a piece of cardboard is used. The connections of these IF transformers are cleaned and retinted before reinstalling them on the chassis. Each one of them had also an extra wire coming out of the can, therefore 2 new wires are prepared and connected. The Ducati mica capacitors used in these IF transformers are protected from external agents only by the distinctive red paint, which in the meantime may have lost its sealing properties. Therefore it seems appropriate to apply some wax to protect these capacitors from developing silver mica disease in the future. In the end, the waxed capacitors are bent back to their original position. These IF transformers require a special 5.5 mm hex socket screwdriver for aligning the ferrite cores. Only later it is noticed that the original holes in the aluminum cans are not wide enough for allowing such a tool to be used, not to mention that having to fabricate a plastic one that would surely be larger than an equivalent metal tool. Therefore, it is taken the decision to enlarge the holes before installing the cans on the chassis again. More cleaning is needed to remove the aluminum filings generated in the process. A metal socket screwdriver is used to verify the correct accessibility of the cores through the enlarged holes. At this point, it remained the problem of fabricating a suitable plastic tool for adjusting the ferrite cores. With some good luck, it happened that I already had what I needed. This metallic marker has a top cap with a hex socket that can be slightly enlarged with a pair of long nose pliers for holding perfectly the ferrite cores of these IF transformers. In 1948, Bertoncini started making their drum RF module, which they used in the models Layla and Malumbra. It is a very large component, hosting antenna and oscillator coils and trimmer capacitors. It is important to observe that the coils do not have ferrite cores, therefore there is only the possibility to do the alignment operating with the trimmer capacitors. There are 2 groups of connectors. At the front there are those related to the antenna coils and trimmers. The others are those related to the oscillator coils and trimmers. The drum is divided into 4 modules, one for each band. However, the arrangement may be initially counterintuitive. The coils are attached to the board containing the connectors to whom they belong, but the trimmer capacitors are connected to the next board so that they remain accessible for the RF alignment when the band that they belong to is selected. The reason becomes clear when it is the time for the alignment. In these accelerated clips, some cleaning of the RF module is visible. Ideally, because of the amount of dirt that this component was able to accumulate over time, the dishwasher would have done a very good job. However, it is better to avoid any kind of violent wash when there are Litz wires around which could so easily be destroyed just from the water jets. Also, the alternative of letting the component soaking in a detergent fluid was put aside because of the body of the coil made of paper and wax. Here, for the cleaning, alcohol is used together with cotton swabs and a lot of attention. The result is not perfect, but most of the dirt gets cleaned. In the end, also the mica capacitors are sealed with wax to prevent them from deteriorating. The separate board that is used for making contact with the selected drum section has two small additional holes that were not used by the factory, which are just perfect for fixing the aluminum bar used to short the contacts to ground whenever they are not touching a selected band section. Two very short M2.5 screws fit very well in the holes and do the job. This radio is supposed to have a field coil loudspeaker, and not the replacement that was found in the cabinet when it arrived. It was possible to find a speaker that resembles very likely what was the original one of the radio, even though it came from France. Also, the DC resistance of the field coil corresponds to the value in the available Layla schematics. However, this new speaker requires attention, starting from treating the rust spots with a gel rust remover, continuing with some cleaning, and then finishing with repairing the cone. These clips show the process just described. After cleaning, the cone is repaired using the paper of tea bags and a glue that remains elastic also when it is cured. In the end, all the cone internal surface will be covered with glue because the paper that was used is now brittle and would be broken soon otherwise. When the glue is cured, the space inside the voice coil is cleaned with a little piece of paper. The loudspeaker came with its output transformer, and it is important to measure the impedance of the set. For making a comparison, also the impedance of the previous loudspeaker and output transformer is measured. In this case, the measured impedance appears much higher, and it is considered the possibility to swap the two output transformers. Unfortunately, the new combination of loudspeaker and output transformer gives a lower impedance, and the original output transformer of the French loudspeaker is preferable. Before putting aside the speaker, a piece of cardboard is cut around the shape of the basket to protect the cone from accidents until the speaker is ready to be installed in the cabinet. Also, the speaker set connection is prepared using small automotive spade connectors. Before starting the reconstruction of the circuit under the chassis, a decision is taken regarding a few final amendments. This is the reconstructed original schematic diagram, and this is the slightly modified version that is going to be built. Apart from the fuses, there are halogen light bulbs in parallel before the power transformer to drop some voltage, and an additional one in series with the B+ for protecting the field coil and the output transformer in case of failure of the electrolytic filter capacitors or other components. The capacitor C20 is connected in parallel with the primary winding of the output transformer. The final measured voltages are already visible in this diagram, although they have been taken at the end of the process of reconstruction of the radio. Here is the map of the components under the chassis according to the amendments. The power transformer is installed again on the chassis, but this time it is kept slightly elevated from it. The secondary winding terminals are then connected. The red wires are for the rectifier tube filament, the blue wires are the high voltage for the rectifier tube plates, the black wire is the center tap for the ground connection, and the yellow wires are the 6.3 volts for the rest of the filaments. The original power cord was connected to flat posts that don't seem right for the purpose because they would be too close to the surface of the chassis. Therefore, a common terminal strip is installed instead. The radio is going to have 2 fuses and 4 halogen light bulbs for dropping some voltage from the mains, which nowadays provides 230 volts instead of 220. For hosting the fuse holders and the light bulb sockets, a small plastic box is prepared. The 4 light bulb sockets are connected in parallel. For making sure that the fuse holders will not turn while inserting or removing the fuses, it is better to lock them using some super glue. A new power cord is prepared. It must be connected directly to the fuses, then it must go into the plastic box. In this case, 2 grommets are used with the function of strain relief. When the cable is in its final position, some super glue is used to lock everything in place. The 4 light bulb sockets, in parallel with themselves, are connected in series with one line coming out from its fuse. The 2 lines after the fuses and the light bulbs with the external ground wire are extended and braided together. Finally, the box is installed on the chassis using 2 small self-tapping screws. One of the 2 lines, ideally the neutral, is connected to one terminal of the primary winding of the power transformer. This is done using the original input voltage selector, but in a way that would not allow to choose anything different than the 220 volts. The other line will be connected straight to the power switch and then to the other terminal of the primary winding. As for the wire coming from the external ground, that is connected to the chassis. For testing the work already done, it is necessary to put 2 fuses and at least 1 light bulb in one socket. The power transformer was tested already before. Therefore, for this test, a lower input voltage is used, enough to verify that the connections are correct. The reconstruction job continues, and another terminal strip is installed for putting an extra halogen light bulb, but in series with the B+ source, before reaching the first electrolytic filter capacitor. This additional light bulb is meant to save the field coil and the output transformer in case of a short circuit on the B+ line. This is done because the fuses may be not enough for reacting properly after a short on the B+ line. This is a new tone control potentiometer containing the power switch that was not connected before. It is linear, therefore a resistor is added between the wiper and one end to obtain the wanted maximum value, but with a logarithmic progression. However, at the moment the position of the resistor is wrong, and it will be corrected later. The original electrolytic filter capacitors of this radio model must have been of a square-shaped type typical of that time in Italy. Those capacitors were usually installed under the chassis, and, in fact, there is no space on the chassis for a common capacitor can. This is the original post for connecting the two filter capacitors, one before and the other after the field coil. The volume potentiometer contains a double switch. One of them is used to cut the B+ power to the tubes that are not involved in the audio amplification when the phono input is used. Therefore, it is cleaned and installed already in this early stage of the circuit reconstruction. The early part of the B+ line involves the connection to the loudspeaker set because of the field coil and of the output transformer. Typically, only 3 wires are needed for that. As already mentioned in a previous section, spade connectors are used to make it easier to attach and detach the loudspeaker set when necessary. The process of reconstruction continues. A yellow wire is used for providing the filament power to all the tubes. The new filter capacitors are installed on the original elevated post. Also, the remaining components in the audio frequency section are installed. The test is done by inserting only the rectifier tube and the final amplifier. The voltages are tested, and then some audio signal is injected at the volume potentiometer. It is now the time for the intermediate frequency and detection section, but also something that was left behind in the audio frequency and power supply sections is now completed. The original top caps were silver-plated and now are completely tarnished. The gel rust remover already used in this restoration project is also good for removing tarnish, although with it also the residues of silver plating are lost. At this stage, it is possible to inject the modulated IF signal only before the second IF transformer. And so far, everything seems okay. The mixer and oscillator section is also rebuilt. The area around the tube type ECH4 needs to be shielded. Therefore, the original piece of aluminum that was used for the purpose is prepared with a couple of wires for obtaining proper grounding. The aluminum shield seems to be too wobbly. Therefore, for now, some hot glue is used to make it a little bit more stable. Like in the previous section, the remaining top caps are treated with the same product for cleaning them from old tarnish. The variable capacitor is a standard Ducati model with two double sections having a maximum capacity of 128 plus 456 picofarads. In this case, the section with 128 picofarads used by the oscillator is wider compared to the one used for the antenna tuning, but there seems to be no particular reason for that, except maybe to occupy a space that would remain unused otherwise. The variable capacitor of the unit under restoration was washed in the dishwasher, and now it is cleaned from the residues of peeling paint, lubricated and greased. The old wires are removed, and the contacts are cleaned and re-tinned. Afterwards, new longer wires are soldered and insulated. The variable capacitor is placed again on the chassis. However, one should not forget to put the original spacers. The design of this radio does not require keeping the variable capacitor metal frame isolated from the chassis with grommets. Nevertheless, it seems convenient to use nylon washers instead of harder metal locking ones. For now, only the ground connections are soldered. Everything else is waiting for the band switch selector, which is not returned in the chassis yet. Before installing it, the drum band selector is lubricated where appropriate using Vaseline oil. The module is inserted and laid inside the chassis. Two screws are then inserted from underneath to hold it in place. A screw is inserted on the front for holding the long bracket of the RF module. Then the bracket can be lowered for reaching its final position on the chassis. The board containing the two sets of contacts is inserted in its position, but placing the three screws used to hold it in place is not an easy task. It works. The mica capacitors used in this radio were sealed using only some red paint. These capacitors are still working correctly, but the seal is not reliable anymore. Therefore, they are protected by covering them with hot glue. This is the example of the largest of these capacitors. However, be aware that this is experimental and not standard practice. This is the result of another smaller capacitor of this radio. The last work under the chassis is done to bring the radio back to an operational condition. The unit arrived with this strange component, which turned out to be a capacitor of a very low value for the obvious purpose of better aligning the oscillator with the antenna section. Unfortunately, during the last phase of the rebuilding process, it gets broken and it is replaced with a common trimmer capacitor, initially set to the same value of the original one. A piece of cardboard is necessary to insulate the shield, which would touch the terminals of the oscillator mixer tube otherwise. The tubes are inserted again in their sockets and the chassis is tested. It works. An RF buffer is going to be built for this radio. This is the schematic diagram and the plan for building it on a standard prototype board. The RF buffer will be used for collecting the signal from the tube type ECH4 at the plate of the oscillator section. The board will be hidden inside a small plastic box, which is also meant to hold the BNC connector for the output. With no more comments in this section, this is the full process very accelerated. the RF buffer works. However, in the lower part of the medium wave band, it picks an harmonic which is responsible for a false reading by the frequency counter. However, all the short wave bands are read correctly, and that is comforting. One last look under the chassis. With the variable capacitor fully opened and the multimeter connected to the AGC line, a signal at 467 kHz is injected at the input grid of the tube ECH4. The cores of the IF transformers are adjusted using the bottom of the pan that was shown in a previous section to read the most negative value on the meter. Later, in place of the multimeter, an oscilloscope is connected for reading the same negative voltage, but with a more dynamic visualization. Then, the signal generator is set for sweeping between 462 and 472 kHz for verifying the shape of the bell curve, which appears upside down. Later, each of the four bands is selected one at a time. The signal is injected into the antenna input with the variable capacitor half-meshed, tuning the signal generator into the frequency that produces the maximum output. Then, the antenna trimmer of the selected band is adjusted for obtaining the maximum output signal corresponding to the most negative voltage at the AGC line. This with the purpose of aligning the antenna and the oscillator sections in the drum band selector. Unfortunately, although in relatively good shape, the dial glass came without the frequency range of each band, and there is no data about it online. Therefore, the alignment of the oscillator trimmers is not done, because there is no point of reference on the dial scale that should be respected. On this radio, the dial panel is a very important part of the chassis structure for allowing the tuning and the representation of the tuned frequency with the dial indicator. In fact, completing the installation of the front panel takes many small steps. After repainting the surface with a new uniform opaque white color, the first thing to do is installing the shaft responsible for tuning the radio. It needs its own bushing. This shaft was meant to drive the variable capacitor drum using some special iron dial cord, which would make a very good friction, also on very thin pulleys. This iron cord is lost, very likely because it broke some time ago. The plan is to use nylon fishing wire, but it would slip on such a thin shaft. Therefore, some heat shrink pipe is added for getting enough friction on it. However, this will reduce the span of the dial indicator movement on the front which could not correspond to the original dial scale anymore. This pulley holds the shaft on the front panel, and it has the purpose of driving the movement of the dial indicator. On the back of the panel there is a hook where the drum pulley of the variable capacitor can be inserted while it is stringed before being actually connected to the variable capacitor shaft. The new tone control potentiometer has a short shaft that needs to be extended. An adapter is installed for the purpose. A long M6 screw can be used for the extension. It only needs to be cut to the right length. Unfortunately, the adapter brushes around the hole on the front panel. Therefore, it is necessary to enlarge it slightly. Because the panel is made of aluminum sheet, this is done manually using a step drill bit. While the front panel is inserted in position, please notice how easily the drum pulley, which is already stringed, gets inserted on the variable capacitor shaft. It is now time to install the tuning flywheel. The original set screw is ruined and it is replaced with a new one. On the front side, two plastic pulleys need to be installed. It is unknown the original arrangement of the dial cord on this side because it was already replaced with some elastic cord which did not need a spring. The same method is used with new fishing wire of the type already used for the back side, relying on its elasticity. The dial pointer is made more visible using red heat shrink tubing. It is then attached to the dial cord on the front. The dial lamps are meant to be installed on the front panel, and it is about time to take care of them. Originally, only one wire was used to power the dial lights, relying on the ground connection. However, on this occasion, a couple of wires is used for the purpose of not having concerns about the proper ground contact. Also, spade connectors are used to make the dial panel fully removable. LED lights are used, but this type does not have a protective shell, so it must be insulated, and for this purpose a transparent heat shrink tube is used. A piece of paper is temporarily attached to the front panel. Later it will be used for annotating the distribution of tuned frequencies in the various bands. Before going any further, at the back of the chassis the unused holes are closed with screws and the original Bertoncini plate is reinstalled. The original dial glass of the radio came partly ruined, with insufficient information regarding the original wavelength scale. After some research, and also talking to other Italian enthusiast restorers, only a very fuzzy picture of another Layla dial scale of the same period could be found. Even though the wavelength scale is not visible, it is remarkable how many other differences can be noticed. This radio model went through important amendments not only to the electrical arrangement, but also to the dial glass in a very short amount of time. Therefore, there is no point in aligning the RF section to the dial scale. What matters is that the antenna section tracks sufficiently well with the local oscillator. However, for the purpose of redrawing the dial glass, the wavelength scale is reconstructed based on the actual reception, using as a reference the local oscillator frequency, subtracting the IF frequency of this radio, and obviously translating it into meters. Here is the redrawn dial glass, which could be found with better resolution in the written documentation that comes along with these videos. It is curious to observe the strange way that an Austrian station was spelled on the scale. It must have been a spelling mistake, but it is kept as it is in the redrawn dial scale for memory. Anyhow, the original dial glass is cleaned carefully, and a few corrections are done using a simple black marker. Then it is sprayed on the back with clear lacquer to preserve the surviving original writings on it. Before putting the dial glass on the front panel, the metal round band indicator must be taken care of. It is cleaned with acetone, then it is treated with a gel rust remover, then it is painted again, and finally a new label is glued on. In place of the original rubber, pieces of an old inner tube of a bicycle are used. What remains to see in this section should be self-explanatory.
The pair was born. A naming competition is underway, asking residents for.
The cabinet of the radio is very light, built using veneer around a thin wood skeleton. Luckily, it arrived in very good shape. On the back there are old nails that very likely were used to put rotating metal flaps meant to hold in place the back panel. They will not be used after the restoration, therefore the nails are removed. The original loudspeaker panel is removed. It is partly broken and is held in place by screws and also nails. The cabinet front panel could be extracted, but that has not become apparent yet. Therefore, the grille cloth is removed in this awkward way. The front panel is kept in place by a few wood blocks, just nailed to the wood frame, on purpose without glue. It is sufficient to extract these small wood blocks to release the front panel. With the front panel extracted, it is much easier to clean it from the residues of the old grille cloth and from other dirt as well. The main body of the cabinet is also cleaned. It is in such a good condition that it does not need to be repainted. The original loudspeaker panel is broken, and it is appropriate to make a new one. In this case, some plywood obtained from an old picture recovered from a dumpster is used. The original grill cloth was very thin and fragile. Some thicker cloth is chosen for replacing it. The same floral pattern was used in other restorations of this series. The flowers will not be much visible from the grill itself, but the colors have some relation to those of the dial glass. The cloth is glued to the grill using some contact adhesive, applied using a very thin paint brush. Even though there is only one loudspeaker, the grill cloth is needed also on the opposite side of the front panel. Very likely the cabinet was designed to operate as a sound box. Once the glue is cured, the excesses of cloth are cut. The front panel is inserted again in the main cabinet body, and the original wood blocks are reused using the same nails, inserting them in the same original holes. The function of these wood blocks is only temporary, because the front panel will be kept in place by the pressure of the chassis on the dial frame. The newly made loudspeaker panel is installed as well. The holes for the screws have been made in the same places as the original piece of wood. After checking again that the voice coil can move freely, the loudspeaker is installed on the speaker panel. For some reason, the wood bars at the bottom of the chassis were not made thick enough for the correct vertical alignment of the chassis itself. Therefore, already by the factory, some spacers were added. Later, in some previous repair, that space had to be increased. Therefore, now the remaining original spacers are removed and two stable wood strips are put in place and adjusted as necessary. The chassis can now return in the cabinet. When this is done, also the loudspeaker set is connected. The radio arrived with the original knobs. They were fairly clean, but they are now cleaned again anyway. The original set screws are consumed, and they need to be replaced. This is done using regular screws because there is enough space, and the chassis is electrically connected to the external ground. The original back panel of the radio is in very bad condition, and the accident that ruined it also significantly damaged the components on the chassis. Due to the particular shape and size of the cabinet, it is judged safer to make a metal back panel using a pre-perforated sheet metal to be installed more firmly on the wood frame of the cabinet. The metal sheet was cut using a big pair of shears, but no footage was taken out of embarrassment for not knowing well enough how to proceed. Luckily, the result was decent enough. For holding the metal back panel in place, Some brass washers are soldered around the panel. When the washers are in place, it is possible to identify the areas where the panel needs holes. Later, the holes were made off camera, trying different methods. In the end, a large step drill bit was used, and the sharp borders were covered with hot glue for obvious safety concerns. Here are the parts that have been replaced. As usual, the smaller components will be kept at least for a while. The frequency counter is connected to the output of the RF buffer, and it is configured for the intermediate frequency of 467 kHz. The test is done in an early rainy morning just before sunrise. The time of the test is chosen for allowing the reception of something in all bands of this radio. The test starts from the first shortwave band.
В эфире «Путешествие по Китаю». У микрофона ведущая Мария. Продолжаем наш рассказ о Юэн Минюэн. Три независимые друг от друга, но соединенные воедино части. Первый сад
Shortwave 2. Shortwave 3.
Bueno, saltando metas, suponete una línea de internet proporcionando que se comuniquen, ¿no?
سيعلن كلارو يكلني ما دين بروفيسور فتفرق سدا ترى كلاسي سدنا ما عادش ما نبترم ده يكرب كاكا.
Ham radio communication.
Tenga una propiedad de una vivienda, en fin. En el lenguaje burocrático es muy
Medium wave band. At a certain point, below 800 kHz, the frequency counter becomes useless because the signal provided by the local oscillator contains an important harmonic frequency that leads to a false reading.
Non je počítáte dílu, tam je také fyziky, kteří ležá původ rodiny za horoskopy ošťívance. Se na táta?
adesso arriva la nota seria, prima una fisica verso arrivate da... Tiene el canal 24 horas.
91, puedes imaginar a qué se refiere. Vamos a mirar en arroba las mañanas de Mac RNL, la cuenta del 15% que votan no está de acuerdo con la expulsión de Vox. Hasta el momento son ingresos.
A másik az, amikor egy titkosszolgálati műveletek fedésére címkéznek